Hey everybody! So let's get some answers to this homework about the fundamental counting principle. It's all about decks of cards, actually. Question number one is whatever you put is fine because it was, did you believe it? Question number two was your best guess. It did not matter what you wrote. Question number three, the problem with jumping from an 8-card deck to the 52-card deck was that we'd actually not be able to jump from 8 to 52. We'd have to actually go and do 9, then 10, then 11, then 12. We set up, unfortunately, the pattern for 8 was based off 7, and 7 was based off 6, and 6 was based off 5, and so forth. So that was the problem there. Number 4, again, is going to be exactly whatever you put because it's your why or why not. Whatever your sentences you wrote were great. Quick little factorial practice, 10 factorial, 12 factorial, 20 factorial. We can use Google to do all those. 10 factorial is going to be right there, about 3.6 million. I don't know why all this is up here. I guess 10 exclamation point makes it think of something. I have no idea why. Anyway, 3,628,800. Oh, it's a movie. That's why 10. Fun. 12 factorial. We can change that 10 to a 12. See if that's a movie. Nope, no movie there. That's 479 million. It's amazing. Only went up by 2 from 10 to 11 to 12, and yet we picked up hundreds of millions more. And then 20 factorial is going to be massive. That's going to bring in the scientific notation, I guarantee. Yep, there it is. So you're talking about oh boy, I don't know what 18 is. 12 is trillions. 15 is quadrillions. 18, that's about 2 quintillion. That's a huge number, just massive. Okay, and then number 6, if you want to see this worked out with actual decks of cards, you can watch the Zoom videos from this day, because I actually did bust some cards out to actually use them, which was fun. But I can also do this using like a chalkboard, like a Word document chalkboard. I'll make one up right here for you. Pull it over. Okay, so I'm going to go back to 52 factorial for a second. Let's make it bigger so we can see it, and let's also lay this out landscape. All right, so 52 factorial, as you said, was 52 times 51 times 50 times 49 times 4. I'm going to stop, and then we're going to go dot, 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 and then we're going to go times 4 times 3 times 2 times 1. Okay, and the reason it is this, forget the fact that it's called something special like a factorial. The reason it says this is you have 52 choices for the first card to fall, then 51 because you didn't put that card back, then 50, then 49. So you end up having 52 spaces that are filled with cards, and this tells you the number of choices you have for each of those spaces. So you have to actually envision 52 cards all laid out. As a matter of fact, here, let me just show you using random.org, one of my favorite websites, random.org. We can actually I'm going to Google cards. This is going to let us deal. No, I don't want to do it that way. I'm going to do random.org, numbers games. I should have done this before I started. I apologize. Here, I'll do it this way. Random .org cards. Here, I'll do it that way. There we go. Playing card shuffler. Perfect. Okay, we're going to draw 52 cards from one shuffle deck. So what you're actually going to see is you're going to see all 52 cards laid out. That's what I'm talking about when you shuffle a deck. So the first card, there are 52 possibilities for this first card. Once that 4 of clubs is down, there's only 51 possibilities left. Then only 50, 49, 48, 47, 46, 45, 43, 44, 45. I'm losing count because I'm... but that's you've got them all laid out. And each time you lay a card down, that's one fewer card than you could get back in the beginning. Let me check something real quick. I wonder if no, we can't. We can't. I was going to try to simulate the experiment I described here, but we can't. So my question here is, start again with a deck of 52, deal the first one out, and make a note of it. So at that point, there are still 52 options. This is number 6 now. there are still 52 options for the first card. So this 52 that's up here, that was 52 factorial, is still 52 down here. Let's go back to here. I lost it. Okay. Then put it back in the deck and shuffle again. Then deal out a second card and make a note of it. Well, if you put the card back in the deck and deal out again, that first card that you dealt is still in there, so you still have 52 options for the next card. And then do it again for the next card. And then do it again for the next card. So where these went down each time because you were leaving cards out of the deck, these are never going to go down because you're leaving the cards in the deck. And actually, oops, this should be dots, not commas. And every time you multiply, you're multiplying by 52 possible cards that it could be, because it always is 52 possible cards. So what you end up with is 52 to the 52nd power, because you have 52 52s. 52 times 52 times 52. The 52nd power. Now this number is massive. Absolutely massive. We'll actually go over here and we'll take a look. 52 to the 52nd power in scientific notation is 1.7 times 10 to the 89th. That is a massive, massive number. And if you want to use the big number calculator, now you remember what 52 factorial looked like. It looked like, if you joined us in class this week, I actually used this big number calculator with you. That's 52 factorial. But 52 to the 52nd power, look how much bigger it is. Look at all the extra digits you get. See that? So it's a massive, massive, massive number, that 52 to the 52nd power. It's amazing you can write it in such a compact way, but it's still such a massive number. Okay, so there's some solutions to homework, and I hope they helped. We'll see you in class.